I'm going to use the standard normal table to find the area or the probability of getting a z-score between negative 2.01 and 0. There's a couple ways to do this using a standard normal table. The first way, I'm going to use the 0 to z table, and what I'm going to start with is sketching the area or the probability that's given, or the area that we're looking for in this inequality, compound inequality. So working with standard normal, the mean is 0, and starting at negative 2.01, a little far out there in the tail. And because I'm in between here, my lower bound for this interval is going to be negative 2.01. My upper bound will be 0. I'm going to be shading in between. Now, the first way to do this is using a 0 to z table. Some textbooks have this version and some don't. It reads the upper half of the table from 0 to positive z. But one thing to recognize is the fact that the standard normal distribution is symmetric. So this is going to be equal to the area from 0 to positive 2.01. Okay, so shading that, these two areas are going to be equivalent. So I can use this 0 to z table, reading down to 2.0 and over to 0.01, which is the second column. So intersecting that row and that column, hopefully not making a mistake here, I get a value of 0.4778. Okay, so this area will be 0.4778. Okay, so that's using the 0 to z table. You could use the z table that reads from negative infinity up to a z-score by recognizing the fact that when we're finding this, oops, my papers are sliding around. When we're finding this area here, the standard normal table that reads from negative infinity up to a z-score is actually going to be reading this area. Okay, it reads left from negative infinity up to the z-score, and we want this in between area. So what I'm going to do is I'm going to recognize the fact that if I shade from negative infinity up to 0, I have shaded half of the area. So I can take half of this, or 0.5, and subtract out the piece I don't want. So using the other table, resketching this real quick, I've got negative 2.01, and I want this area here. I'm going to find this and subtract this out from 0.05. Okay, so looking at the z-table, the cumulative z-table, and I want the page that corresponds to a z-score that is negative, I want to find the area to the left of negative 2.01, so I'm going to read down to negative 2.0 and over to 0.01, and that's 0.0222. So this little tail area is 0.0222. Okay, again, that's not my final answer, okay, because it should be hopefully obvious that this shaded area is more than 0.0222 or more than 0.22% of the total area. So I'm going to take 0.5, which is half of this, the entire half, and subtract out the piece I don't want, and that will give me that shaded area in between. Okay, so that's not negative, that's an equals. Sorry about that. So 0.5 minus 0.0222. I get 0.4778. Now that's the same value that I got when I used the 0 to z table and using the property of symmetry. So I get the same answer here and here. So that's how you find this area using the z table.